So today we're going to talk about Chapter 1, Lesson 3, and this is Properties of Numbers. So you're on your even page. This is on the right side. Today's date is the last day of September. I know, believe it or not. So, couple things. We've got some vocab that's going to show up in here. We're going to see some vocab that we've already written down. But the one vocab word that we're going to write down today is equivalent expressions. And again, the reason why we write down the vocab is because it's used often in your directions, and if you don't know what it means, then it's really hard for you to figure out how to process it. So I'm going to highlight this, just like your book does, because that just tells you that's a vocab word that you need to make sure that you understand. So what are equivalent expressions? So with expressions, we know it doesn't contain an equals. So it's two expressions that represent the same value. The word equivalent means equal, same, and then we have our expression. So these two represent the same value, and there's all sorts of ways that it could be given. So for an example, when you were doing homework last night, you may have had to do some adding. So you may have had something like 8 plus 3 in one part of the problem, and then you substituted in 11 for it because they're equivalent to each other. Okay. Here's one. Let's see if you guys can tell me this answer. What if I have 4K plus 8K? What is that equal to? 12K. That's called combining like terms. We'll talk about that on Friday. Okay. So that's equivalent expressions. All right. So the first group of properties we're going to talk about are called properties of equality, which tell you that there's an equal sign involved in all of these. So properties of equality. Now, a lot of kids, we use these a lot in geometry class, but there's a lot of geometry, again, being brought into algebra class. And honestly, all but one of these we use on a regular basis in algebra when we're solving equations. So I'm going to kind of give you a demonstration of what does it mean, and then how does it look in our class. Okay? It may be something that you never thought about it in that fashion. So first one is called the reflexive property. And it does have the tag of equality. So notice how I kind of do a little bit of abbreviation. That's okay. And basically it says a value is equal to itself. So in very boring terms, we could use algebraic an example where A has to equal A. That makes sense. Numerically, we could say 5 equals 5. We could also numerically say 4 plus 7 is equal to 4 plus 7. Anytime what's on the left of the equals is the same as what's on the right of the equals, that is called reflexive property. Okay, so let me demonstrate how we use this one in our math class. If your directions are to solve for x, what are you going to do to get x alone?
5 minus 3.
Okay, I'm not going to do just 5 minus 3. Because what you haven't explained to me is what did I do to x plus 3? Because this is an equation. Desi? So the reality is to solve any equation, I need to do math to both sides, and I need to do the same math. So how's this reflexive? Well, does negative 3 equal negative 3? Yeah, so I'm taking the same thing away from both sides. That's where reflexive property shows up when I'm doing solving equations. Okay. All right. I'm going to go to the next screen because I wrote too large. Second property of equality is called the symmetric property of equality. The reality is, what I'm trying to demonstrate to you is there is an appropriate way to write answers, and then there's an inappropriate way. Some people haven't emphasized that to you in the past, but we need to be very diligent that we always report out our answers exactly the way they should be reported. Okay, so this is kind of what this is all about. So symmetric property says if one quantity is equal to a second quantity, then the second quantity is equal to the first. So algebraically, we could say A equals B is the same thing as saying B equals A. So what was on the right side now becomes on the left side. What was on the left side now goes on to the right side. Okay? Or let's do another demonstration. How about 4 plus 7 would be equal to 11, and we could say that 11 is equal to 4 plus 7. So I see a lot of this in my daughter's first and second grade classes where they're trying to get the kids with flexibility. Like, what two numbers do I need to add to 11? And then what numbers would give me, or what 11 is the sum of what two numbers. So it's looking at the perspective is just different. It's the same problem. So how does this show up in our class? What are you being asked to solve for in this problem without being told directly? 5 equals x plus 3. Okay, everybody needs to be paying attention. What are you being asked to solve for in this problem, even though they may not have told you directly? X, right? So in my answer, what's the first thing I should see? X. You need to tell me what it is I'm solving for. X. What is its value? Equals number. So the symmetric property allows me to rewrite this equation so that the variable is in the position I want it to be when I'm done. So this is an example of the symmetric property and how we use it in algebra class. Okay? We want things to look a certain format, so symmetric property allows us to pick up. Now notice what I didn't do. Notice that I didn't take x plus 3 and write it as 3 plus x. That's a whole different property we're going to talk about in a little bit. So symmetric is literally picking up something in the order it's written, but just shifting what location it can be found. That's it. Okay, the next one doesn't show up too much in our class. It shows up a ton in geometry class, and that's a transitive property of equality. Kind of shows up. And basically, it's going to sound like a bunch of gobbledygook, so I'm going to just kind of do it with the algebra. If A equals B and B equals C, what can we conclude? Yeah. Notice there's an overlap. They both had a B. So we get A equals C. So anytime you have a situation like that, that's called a transitive property. Okay? So let me give you a slightly better version in numbers that may make a little bit more sense. So let's say you had 6 plus 9 equals 12 plus 3, and you know that 12 plus 3 equals 15. So if 6 plus 9 is the same as 12 plus 3, and 12 plus 3 is the same as 15, what would our conclusion be? Yeah. 6 plus 9 equals 15. So this, again, in the elementary level, it's what are different ways to get 15? Well, I can do 6 plus 9, I can do 12 plus 3, I can do 14 plus 1, I can do 15 plus 0, and so on and so forth. So that, again, could be how it's used. So we don't use it as much because the next one is the one, they're both kind of related to each other, is the substitution property. This is the one we use all the time. And basically substitution says a quantity can be substituted into its equal in an expression. So basically you had some of that last night where you had, I think Paul asked me about one of it, where we had substitute in the values for A, for B, for C, whoever did. And that's substitution. So I was given variables, but then I was also told what the variables equaled. So that is a prime example of substitution. So just a little quickie. If n equals 11, 4n would be equal to 4 times 11, which would equal 44. And again, we use substitution all the time as we are doing math and replacing a problem with its solution. We're doing substitution all the time. Okay, so a lot of what you did last night, you did the substitution property of equality over and over and over and over again when you're doing order of operation problems. So if we have a value n, that's a really pale green, isn't it? So if n equals 11, then 4n would be equal to 4 times the substitution for n, which is 11, and then we could follow up by saying 4 times 11 is 44. I don't know if that helps. Maybe a little bit. So we're going to do one more property, but it's not a property of equality. Okay, one more property, but it's not a property of equality. Actually, no, we'll do it later. Here's what I need you to do on your paper at this point, is you're going to create 2 columns. And these are going to be properties of addition. They can be on the same page for you guys, I just don't have any more room on mine. Properties of multiplication. The next 4 properties work for addition and work for multiplication. It's up in the air, and you can kind of figure it out, and that's part of your homework, I think, on a couple questions, is to determine whether these same properties would also work with subtraction and division. Sometimes they do, sometimes they don't. But these 4 work with addition and multiplication. And then I have a 5th property that's going to work for just multiplication. And you'll know that because of the title of the property. So, first, let's do the identity property of addition. So I think what I'm going to do with these, we'll do some words sometimes, but always an example. Sometimes we'll just do the example. Okay? So on this one, when you add 0 to a number, the answer is the number. So for example, 5 plus 0, I still end up with 5. Okay. Now, 0 is kind of a special number, and he has a special name. 0 is called the additive identity. Now, I'm going to tell you, I don't like what your book does. It calls the property the additive identity property, but that's not its name. It is the identity property of addition, but 0 has a special role. He's the additive identity. So you guys see, additive comes from, it's an addition property. Identity comes from the name of the property. Okay? So this is something to definitely make sure you get under your tool belt. Now we have on the other side, its partner, the identity property of multiplication. So now we're going to talk about when you multiply by a number, we get the same value. So what number can we multiply by and always get the same number we started with? Marlene? 1. So when you multiply by 1 and a number, the answer is the number. So here I'm going to do 5 times 1, oops, come back, equals 5. And we're going to highlight 1, and then we've got a name for him. So if 0 is the additive identity in the identity property of addition, what do you think 1's called? It's like blah, blah, blah. It's the most number of syllables in mathematics. Multiplicative identity. Multiplicative identity. And I'm going to highlight him because you got to know that word. So again, your book, probably when you grade your homework, is going to use multiplicative identity, but that is not the property's name. Okay, that only names 1 in this property. Okay, all right, so let's move on. Next properties are called, they're inverse properties. So we have the inverse property of addition. And this property says when you add opposites, what is the answer always going to be? The answer is always 0. Not sometimes, always. So for example, if I add 5 and negative 5, those are opposites. That gives me 0. So I'm going to highlight the word opposites because that's the key when it comes to addition. Adding opposites, always 0. Okay? Let's talk about inverse property of multiplication. Okay, so in multiplication, we don't use the word opposites. We use two different words. We've written it down in our notes already once. When you multiply reciprocals / here comes the long again, multiplicative commutative inverses, what is the answer? Yeah, the answer is always 1. So I'm going to highlight reciprocals, multiplicative inverses, 1. So again, let's do our example. 5 times its reciprocal 1/5, the product is 1. So do you notice something interesting about the properties one above each other? So identity property and inverse property of addition, do you notice something that's kind of similar between the two of them? Jacob?
All the properties of multiplication have something to do with 1, and the properties of addition have something to do with 0.
Perfect. So these two properties with addition, 0 is involved, but with multiplication and those properties, 1 is involved. All right. Next, let's talk about a couple properties that you've actually known about since probably first, second grade, maybe even kindergarten for a couple of them, and then as maybe second, third grade for the other operation. But your teachers may not have named them. So now we have to put a name to them. So let's draw a line under here, and let me think if I can get through this. Yeah, this one I think I'm just going to do examples. So let's do darker. 5th one is going to be the commutative property. Notice no n of addition. And the commutative property came into play when you were learning about fact families in the lower elementary grades. And your teacher said, boys and girls, what's 4 plus 7? And I got it, 11. Great. And then she'd say, okay, well, what's 7 plus 4? And she says, you already told me the answer. I did? Because that's what the commutative property does. So what happens is when I change the order of what I'm doing, actually let's make this dark. Changing the order of the numbers when I add doesn't affect the answer that I get. So that's our keyword we're going to highlight is order. Okay. And the same rings true for commutative property of multiplication. Oops, 6. The order I multiply doesn't change the outcome. So our example would be if I had 4 times 7, it should give me exactly the same answer as 7 times 4. So when you were learning your multiplication facts, here you thought, I've got hundreds of facts that I have to memorize. Well, they quickly reduced by half because if you understood this notion that 4 times 7 and 7 times 4 give you the same answer, you didn't have to memorize 2 facts. You only had to memorize 1 and know that you could switch the order and get the answer. So we proved 28 equals 28. So again, order is the key word. Okay, so I'm going to highlight that. All right, now I need to go on to my next page. We've got another one that shares. Is everybody good? Can I move? Yeah? Everybody? Okay. So this is our properties of addition. This is properties of multiplication. I'm just going to continue it on. So let's see, we're at number 7. This one is called the associative property of addition. Now this one I'm going to write out in words because there seems to be a wee bit of confusion on this one, so I want to make sure that we've got it down. It says the way you group 3 or more numbers with the same operation, so in our case, adding, does not change the answer. So the way you group 3 or more numbers with the same operation, so on this left side it would be addition, does not change the answer. So what do you think is going to be the word I should highlight that's going to best represent the associative property? Group, exactly. So let's do an example. If I have 3 plus 4 plus 5, so I'm going to write that problem twice. And in the first way, I'm going to group the 3 and the 4 together. So 3 plus 4 is 7. That leaves me with 7 plus 5. I just substituted in 7 for the 3 plus 4. And what does 7 plus 5 equal? 12. I just substituted in 12 for 7 plus 5. On the other side, however, I want to group the 4 and the 5. And according to order of operations, that's the problem I have to do first. So 4 plus 5 is 9. And what's 3 plus 9? So whatever way I grouped didn't change my answer. Okay, Jacob, are you writing this all down? You need to write it down. Now, somebody asked, well, could you group 3 and 5 together and then add the 4 to it? And the answer is yes. However, that's not pure association. Because in order to group 3 and 5, I have to change the order that the numbers appear so that the 3 and 5 would be next to each other. So that would be a combination of commutative and associative. But mathematically, it will work out. Okay. So then over here, I'm going to just brief on this one. Associative property of multiplication. Let's just do the example because it's still about groups. Let's take those same 3 numbers, but let's do multiplication. So the only way the associative property works is if all the operations match. So let's say we decide to multiply 3 times 4 first, which is 12, and then we have 12 times 5 is 60. On the other side, let's do the 4 times 5 first. So we get 3 times 20, and 3 times 20 is 60. Okay? Now, the last one I want to give you actually just goes in the multiplication category. And I'm going to give it 2 names because our book actually uses 2 different names. So this is how I've known it. This is number 9, sorry. This is the zero product property. The book calls it the let's see, how do they call it? It's so weird. Multiplicative property of 0. Oh, I didn't even spell that right. Jeez. Multiplicative property of 0. Okay. What do we know is true when we multiply by 0?
0.
Yeah. Multiply by 0. 0 is the answer. So remember how everybody thinks 0 is this great guy? He's so weird. He does weird things in different places. Okay? Now, I'm going to hold off giving you the example that we would use in our class. It'll come up later on. But what I want to do is give you an example of what you're going to be doing on your homework. So if you aren't already there, let's go to the odd page and let's do one example. So here's what our example is. It's going to ask you, and I'm going to may use some words slightly different. Evaluate the expression and justify each step. In other words, tell me what property we just used that allowed me to do that step. So we have 2 times 3 plus the quantity 4 times 2 minus 8. So because I have more than one operation, I am going to be following the order of operations. Now, if this was a geometry proof, this is what you're given. So in geometry, you're always given some information. And it's based on that information that then what can I conclude? So in that problem, like what you did last night on homework, what would be the first thing mathematically we're going to do? We're going to go in those parentheses, and we're going to multiply the 4 times the 2, and we get 8. What property did I use to change it from being 4 times 2 to being 8? Rory. That's your substitution property. Okay, what would I do next? Desi. Yeah, we're still stuck with doing parentheses, and we get 0. What property says 8 take away 8 equals 0? What property says I'm going to get 0 in that particular case? Okay. Right. Okay. Inverse. When I add opposites, because 8 take away 8 is really 8 plus negative 8, inverse property of addition. Okay. Then what would I do according to order of operations? Okay. So I'm going to do 2 times 3. And that would be substitution again. And what would 6 plus 0 equal? What property allows me to conclude that? Desi? So this is what you guys are going to be doing on some of your problems for homework tonight, is providing the property that allows you to do what you just did. Okay? All right, and then that ends our notes.